Okay, let's look at two things before we even begin. That's a toothpick, and that's going to represent a bond, a bonded pair of electrons. At the end of every toothpick, there is understood to be another atom. So it's two atoms right there, okay? This is a pipe cleaner, what I would call a pipe cleaner. Maybe I'm too old, but pipe cleaner. All right? That's non-bonded pair of electrons. Okay. There are 6 regular geometries. Linear, that's 3 atoms, 2 atoms, 2 atoms, 3 atoms, 4 atoms, trigonal planar, 5 atoms, meaning 4 bonds, and then a central atom, right? That's 5 atoms, tetrahedral. And then this is trigonal bipyramidal, right? That's 5 bonds, right? 6 atoms. And then octahedral, that's 6 bonds and a central atom. Okay? Easy? All right. Now I say regular because if all the outlying atoms were the same, for instance, that was H2, for instance, that would be nonpolar. That would be nonpolar. Let's say beryllium hydride would be nonpolar. There would be no, right? Everything is cancel. That would be nonpolar. Again, if all the atoms are the same, if all the bonds are identical. Tetrahedral, like methane, okay, or carbon tetrachloride, that would be nonpolar. And then trigonal bipyramidal, phosphorus pentachloride, that would be nonpolar. All the atoms, outlying atoms, are the same. And then octahedral, for instance. Okay? Easy? All right, now, if we have those 6 regular geometries, and they would all be nonpolar if all the bonds held outlying atoms which were all the same. All right, now we have irregular geometries where, let's start with octahedral and use that as a parent model. If I remove one atom and I put a non-bonded pair, such as square base pyramidal, right? It would look like this. See? Square base. So there's the pyramid, and then this is the square base, right? It's a non-bonded pair. Clear? See that? That would be square base pyramidal. And then if I removed 2 of the atoms, I would get this. I would get square planar. Okay, that's square planar. Can you see that? Okay. 4 bonds in the same plane, and then above and below you have the non-bonded pairs. Now look how this is the parent model. Okay, the octahedral is the parent. Okay, you see that? Okay. So now let's look at the parent model, trigonal bipyramidal. I remove 1 atom from 1 bonded pair. I get the seesaw. Okay, I get the seesaw. See? I get the seesaw. All right? And that's going to be 4 bonds left over. So what I did was, you see the 3 that are in the same plane? Okay, let's look at the parent model. See the 3 in the same plane? See that? Okay, I'm removing one of those. I get this. See that? It's called the seesaw. Okay, it's called the seesaw because it goes back and forth. Seesaw, 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 seesaw. Okay, see that? Okay. All right. Now, let's straighten these cards a little bit. Okay. All right. Now, if I take 2 off, I get the T. See that? Can you see that? I get, right? So the one that I'm holding is actually the only one remaining in the original plane. See how it stood like this? Okay. If I take the one that I'm handling off and I put a if they was a non-bonded pair, I took the atom off, I'd get this linear. See that? See that? Linear. Okay? And then we'll go to the tetrahedral, which is right here. Tetrahedral. We're going to take one off here. You get the trigonal planar. You see that? Trigonal pyramidal. See that? It's actually not nearly as pyramidal as people think. That's a common misconception. It's actually just quite a bit flattened. Okay? And then there's the angular. It's like water. Water actually comes from the tetrahedral model. See that? Okay? And then we have the trigonal planar parent model. Okay? Take one off there, you get an angular. See that? Okay, and then you get the linear and the linear. Okay? So that's going to be linear, linear, trigonal planar, tetrahedral. This is good. Next one is going to be trigonal bipyramidal, and then octahedral. Octahedral. Okay, we'll bring that down like that. Octahedral. And then we'll bring this over like this. And this is going to be square planar. Okay. Square based pyramidal. Sorry, square based pyramidal. The square planar is here. This is the square planar. Okay. That's a square planar. Okay. Square planar. So square based pyramidal. Put them all in one shot here. And then the octahedrals here. So see if I can get it all in one shot here. Okay. And there you have it. Okay. Come over like that. A little higher. Okay. Get it? Okay. Now let's go to the next one. Bring that up like that. All right. Then we'll bring these four over here. I don't know if I can get this high, how high I can get here. I'm not as athletic as I used to be. Get the linear. Okay, reading from left to right, that's the bipyramidal. Okay, you see that? All right, so I have the trigonal bipyramidal, the seesaw, the T, and then the linear. Okay, good. And then the other three, this is easier to get. Okay, try to isolate that. It's easy. Tetrahedral, trigonal, pyramidal, and angular. Okay, that's that family. Okay, we're calling them families because I can actually derive one from the other. Okay, and then the trigonal planar and the angular. And then, not necessarily families, but the two linears left over. Okay? Enough for now, and goodbye.